Hi, welcome to Algebra 2 Common Core. Today we're going to talk about functions. Let's review the definition of a function that we saw back in Algebra 1. A function is a rule that assigns exactly one output Remember that our output value is always going to be our y value. For each input value, which is our x, we always call the input the independent variable, and our output is the dependent variable. Perhaps you've seen these terms in your science classes as well. Now we'll take a look at the exercise number 1. An internet music service offers a plan whereby users pay a flat monthly fee of $5 and can then download songs for 10 cents each. We want to identify what our variables are. Our independent variable is going to be the number of songs that we want to download. The dependent variable will then be the cost of downloading those songs. So we can take a look at the table of values and evaluate some of the costs associated with downloading the songs. If, for example, we download 0 songs, the only thing that we are paying is $5 for the monthly fee. If we download 5 songs, 5 times 10 cents each is 50 cents, and we add on the flat monthly fee of $5 and end up paying $5.50. If we download 10 songs, 10 times 10 cents each is $1. $1 plus the $5 gives us a total of $6. For 20 songs, 20 times 10 cents each gives us $2, plus the $5 flat monthly fee gives us a total of $7. So the equation that we could use that would model y as a function of x would be y equals our flat monthly fee of $5 plus 10 cents for each song that we download, so we're going to have to multiply 0.10 times x. We could enter this equation in y1 on our graphing calculator. That would allow us to get a table of values for the interval from 0 to 40. So making my table of values, X will stand for how many songs we're downloading. Y will stand for the cost. I'm not going to do every number between 0 and 40. How about if we count by 5s? So 0, 5, 10, 15, 20, 25, 30, 35, and 40. Now at this point, if you need to pause the video, you can enter this in your calculator and make the table of values. You can also look above and see that we've already started the table of values. For 0 songs, we know it cost $5. For 5 songs, $5.50. For 10 songs, $6. For 15 songs, $6.50. For 20 songs, it was $7. Hopefully we're starting to see the pattern that for every 5 songs, we go up by 50 cents. So 25 songs would be $7.50, 30 songs would be $8, 35 songs would be $8.50, and 40 songs would be $9. We'd like to plot these points on the graph given. So I'm going to try to plot starting at 0. I want to put a dot at 0, 5. Since my interval on the x-axis is going by 2's, I think I'm going to skip the 5 and go to 10. And at 10, I want to plot $6, so that would be this point right here. At 20, I see that I want $7, so I'm going to plot that point. At 30, I've got $8, so that would be this point. And at 40, I've got $9 right here. Trying to make a nice straight line. I see that here is the graph representing this problem. Now the question for you to think about, is this graph a function? How would we know if it's a function? Maybe we should ask ourselves if for every x value, is there only one possible value for y? If that's true, then we would say, yes, this is a function. For exercise number 2, we're given 2 graphs, and we're asked to decide if these relationships are functions and how we can tell. Again, going back to our definition of a function, if for every x value there is only one y value associated with it, then the answer is yes, it is a function. We could pick an x value. So for example, what if we pick x equals 3 on both of these graphs? Looking at relationship A, when I count over 3 on the x-axis, I see that here's a point and also here's a point associated as outputs for x equals 3. That tells me that I have the ordered pair 3, 4 and 3, -4 on this graph. Because there are 2 y values associated with the one value x equals 3, we would say that this one is not a function. It doesn't follow the definition that we are given. If we try relationship B, going to the same point, x equals 3, I see that I have only one point associated with that one. So for example, at the point x equals 3, the y value is -2, and there is no other output at that x value. No matter what x value I look at, each x only has one y associated with it. So I would say that relationship B is a function. When we're given a list of ordered pairs, it's pretty easy to tell if I have a function or not a function. When I examine the list, I should be looking for every x value, making sure that each x only has one y. So in the example A, I see that those 3 ordered pairs all have different x's. Because they all have different x's, I don't even really need to pay attention to the y's. This is a function. However, in example B, I see that there are 2 different points, 1, 3, and 1, -6. The input of 1 has 2 different possible outputs. Therefore, example B would be not a function. What do you think about example C? Look at the list of ordered pairs and decide if it's a function or not a function. If you said not a function, you would be correct. Did you find the ordered pairs that make it not a function? We should see 5, -7 and 5, 0. Both of those have inputs of 5, but the outputs do not match. So 2 different outputs means that I do not have a function. Now, what if I'm given an equation instead of a graph or a list of ordered pairs? How will I decide if I have a function or not? If I have the equation y equals x squared minus 4, one way that I could decide if this is the graph of a function is by looking at the graph. So take out your graphing calculator and type in y1 equals x squared minus 4. When you do that, you should see the graph of a parabola. Here's a sketch of the axes. And the parabola would look something like this as a rough sketch. If I go along and look at each x value, I see that it only coordinates with one y value. If I look at the table of values on my graphing calculator, I see that every x only has one y. It's okay that the y's do repeat. It's not okay if the x's repeat. So this one is a function. When I look at example B, I see that I've got something that I actually can't graph on my calculator because it has a y squared in it. So I'm going to look at this one algebraically. This one I am going to say is not a function. And the reason for that is because when I look at particular values of x, for example, what if I try x equals 0? When I substitute 0 in for x, I see that y squared is equal to 16, so y can have an output of either positive or negative 4. Two different output values tell me that I do not have a function. If I try example C, again substituting values in for x, no matter what x values I pick, I'm only getting one answer for y. So this one is a function. I could just as easily have graphed this on my graphing calculator, and my graph would look something like this. Every time I look for an x value, it only has one y value associated with it. So in summary, how do I tell if I have a relation that is a function? The ordered pairs or a table of values is by far the easiest way to tell. I look at the list, and if every x value has just one y value, then I know that I do have a function. Graphically, you learned something back in Algebra 1. Maybe you're thinking about it right now. This was called the vertical line test. If I'm given a graph and I want to know if the graph is or is not a function, I can just draw vertical lines. And if every vertical line only crosses the graph one time, then that means I do have a function. Last, if I've got algebraic equations like the last example, I can approach it in a couple different ways. First of all, I could test inputs and outputs. Try some different values and see if for every x value I only have one y value. I could also, if possible, graph it either by hand or on my graphing calculator. And if I've graphed it, I can then use the vertical line test. I'm going to abbreviate that VLT for vertical line test. And that's another way to tell if I have a function or not a function. Here are 3 examples that we'd like to look at and decide if we have a function or not. Pause the video for a minute and see if you can decide if it's a function or not a function. I use the vertical line test. If you draw any vertical line and count how many times the graph crosses that vertical line. The first example is a function because each red vertical line that I drew only crossed the graph once. However, the second example is not a function. If even one of the vertical lines that I draw crosses more than once, that means that there's an input for which there are two or more outputs. In this case, two outputs at the number 3. Same thing happened with the third example. If I draw a vertical line at the number 1, I see that there are two outputs at the number 1. So this one is not a function as well. Make sure that you review the definition of a function and all the different ways of determining whether something is or is not a function. We'll be discussing this more in class tomorrow. Have a great night.